Good morning, everybody. Um, I apologize that I was a little late in showing up this morning. Turns out when you get sick and don't, you know, fall asleep, apparently it's hard to wake up. So I am awake now. At least I think so. Otherwise, this is a really bad dream of mine. Um, who knows anymore, right? Anyways, I apologize for how low quality this is. I wish I was in person, but I don't want to get anybody sick, and I've just had some very swollen tonsils that will not stop being swollen. So at this point, I don't really think I'm going to be coming back for the rest of this week. And next week I have jury duty, so next week I won't be here either. In any case, um, let's go ahead and talk about this class. So this is EGR 325. If you don't know who I am, my name is Dr. Cale Stoley. I am a professor of, well, an assistant professor of engineering here at Tone. Um, let's dive into uh, the syllabus. So we're going to talk a little bit about what we're going to do in this class. What is the purpose of this class? So this is Introduction to Electronics and Electrical Circuits. That's what we're going to be doing in this class. I know, it shocked me as well. I did not realize that the title of a course was so closely tied to its content. This is the textbook. This is required for you. This is actually one of my favorite textbooks. You will need to purchase this textbook. Hambly is a very good author. Fun fact: when I took electrical engineering when I was in college, I also used Hambly's book. Now I had a really bad professor who he would show up and then he would read us the example problems out of the book, and he would do it terribly, and that was our lectures. So yeah, it was not good. The one thing that was really good about that class is that he had really hard tests. So I had to teach myself electrical circuits alone so that I could pass his friggin' hard tests, because he didn't teach us. I stopped taking notes in class because I realized it was an absolute waste. But thankfully for you, your teacher is only mediocre, so you should take notes. But you will make sure to get that book. I also encourage everyone to get a Raspberry Pi. Now this is you don't have to get a Raspberry Pi. I'm not requiring it. It's not something that absolutely every person has to have. In years past, I've tried to put together a Raspberry Pi kit. That has not worked well because I wanted to sell it through the Doan bookstore, and well, it just was a disaster. I have not had a good times with that, and with current supply chain issues, who knows if we're going to be doing it this semester either. But we do have a few Raspberry Pis here, and I would encourage you to try to get one if you can, because it's a really good learning instrument. It really helps you dive deep into electrical circuits and electronics. Um, in the future, I probably will require students to buy a Raspberry Pi, but not right now because, um, supply chain problems. If you're making things fun and trying to order things from China, most of this stuff is boring. There are a lot of work things that you're going to have to do for this class. Now you will, if taking a look at this, you will notice there's no homework assignments. I've made a bold decision this year that instead of homework assignments, I would rather do lab reports. To me, you will have quizzes, and the quizzes will be frequent, and they will be some hard questions. The quizzes hopefully will prepare you for the exams because they're the same format, same style of questions. But but I'm not giving you homework assignments because I would rather that you work on the practical applications of a lot of this coursework. To me, it's important that you understand the material, and in years past, I've given homework assignments, and they were just book problems that you could just find the answers on Chegg, and it's like, why am I even giving you problems that you can find on Chegg? Awesome. But this is the breakdown. We will have 2 projects as part of this class. You'll get some details on those later. This is the expected progression of this course. This first week we're going to be talking about power, energy, voltage, current, and Kirchhoff's laws. It's a whole lot of topics to cover. Chapter 1 is it kind of comes fast, and it kind of comes hard too, because it's not exactly easy course content. In the third week, this will be the week after I get back from jury duty. Assuming I survive being sick, who knows if that's going to happen. If I don't survive, I guess everybody gets an A, right? But in the third week, we're going to be doing some soldering. We're going to be talking about Raspberry Pi stuff. If you can get it in by January 25th or 27th, that'd be great. If you can't, at least try to get it in by the next week when we start doing our lab. So just keep that in mind. We are going to be covering a lot this semester. This is not an easy class, and I have a little bit of a spiel that I give whenever I do this class. You're going to get it right now. So this is a hard class. For those of you who have taken a class with me, this is hands down the hardest class you will have taken with me. The classes that I teach at a freshman level do not expect anything out of you. They don't expect you to have any competencies. They don't expect you to have any kind of knowledge. So when you go into these courses, you're not seeing me at my finest. I expect a lot out of you in this class. It's a hard class. This is a 300 level course. It requires a substantial amount of cognition, because it's not easy concepts. And I'm not trying to scare you out of this class. If you're an engineer, you have to take this class. So there's no merit in me trying to scare you out of it. This is one of my favorite classes to teach, but part of it is because I really do get the chance to really kick your butt. And yes, I mean that in a nice way. I enjoy watching students grow and develop, and this class is an opportunity to really watch you grow and develop as a young professional. We have to deal with very, very challenging concepts. This isn't something that anybody can just walk in off the street and figure out. We're dealing with DC circuits, AC circuits, construction of circuits, using Raspberry Pis. We're going to be integrating coding into physical construction of circuitry, and quite frankly, that's intimidating for a lot of people. And I am not at all going to point at this and say that you should have an easy time here. This should be hard. This should be something that you feel like you are challenged in this class. And I will challenge you. It's a 4 credit hour class. So just keep that in mind. Now, I also will say another piece of this. One of the reasons why I enjoy this class so much, one of the reasons why this class is so challenging, is because the last time I saw you, some of you hadn't even taken calculus yet, or hadn't started taking calculus yet. Some of you had really just not, you were just starting college. At this point, you've been through a whole lot in your college careers. This It's been a challenging journey so far, and I can confidently say that because this is a tough class. In order to get into this class, you had to have gotten through some tough classes. This is a um, a class that exists in a series where it's kind of not even the end, because there's more classes that come after this one. Um, but you had to have really endured a lot of challenging course material to get here. So I applaud the fact that you are here. It's taken a lot of resolution to get here, and I don't um, I don't take that lightly. I don't disrespect you. I will treat you as engineers, but at the same time, I am going to expect you are adults. In order to be successful in this class, here's what you have to do. Number one, you have to do all of the work that I give you, okay? If I give you a quiz, you got to do it. If you rely on someone else to do it, you will never understand the material, okay? I do give challenging quizzes, and I'm not going to sit there and make sure that you do them alone. All my quizzes are offered online through Canvas. I give you a week to do them, so you can work on them on your own time. I'm not going to follow you around and make sure that you are working by yourself, or that you are understanding all of the quiz material. That's kind of on you. If you don't understand something, or you don't understand why you're doing something, you should ask questions about that, okay? We exist in a close-knit community where you have the ability to come and ask me questions every time you have a question. You should be asking questions, okay? This is not easy stuff, as I've said. So if you're falling behind, or if you're not really understanding the material, or you're getting the homework done, but you really need somebody else's help to do it, I guess not homework, but you're getting the project work, and you're getting the quiz work done, and you're getting the reading assignments done, you have no idea what's going on, come talk to me. Ask questions. There are no dumb questions here. If I can help you understand material, and it takes me 5 seconds, great. Everybody saves time. Some people are afraid that makes it sound like it's a dumb question. There's no dumb questions. If it's going to take 5 seconds of my time to make your life easier, that's not a dumb question. That's a good question. Okay? So, number one, you need to be asking questions. You need to be figuring out if you can understand the concepts. Number two, you need to be taking notes in class. Okay? Notes are kind of essential. If I say something, you should be writing it down. Now, that doesn't always come off true, because I say a lot of dumb stuff. Often, I've been known to maniacally laugh. I've also been known to curl up in the fetal position. Yeah, I said that on YouTube. Dang it. I've even been known to say dumb stuff online. But in general, if I'm writing something on the board, if I'm giving you course information, you should be writing it down. It's important for you to understand the material. It's important for your growth. Overall, you just need to be cognitive of the processes that are going on here. I'm going to be doing examples for you in class, and they're going to be challenging examples. I step through absolutely every step of my process. If I don't write something down, but you feel like it's important, you should be writing it down. That's part of the note-taking process. In this class, the students who always do the best are the students who take the best notes. Just hands down. You should be reviewing your notes. If you take notes and you just throw them away, there's no real merit to have taken them in the first place. Well, other than that taking notes does make you a better individual, but whatever. Taking notes actually does assist you in remembering material, but it's better if you review them later. You're going to want to read your textbook. Okay, I'm going to give you reading assignments. You're going to need to use your textbook to do them. Understanding material that's in the textbook. Textbook is a second teacher here. Okay, I am a first teacher, but I am not your only source of instruction. I'm requiring you to use your textbook so that you get two perspectives on the same topics. You read the textbook gives you one way of doing stuff. You come to class, I give you another way of doing stuff. I explain my reasoning, the textbook explains its reasoning. Hopefully, between the two, you find a method that makes sense to you. So that's why I require you to use your textbook. I really like the textbook, as I've said. Uh, this class is the reason why I started doing reading assignments at all. Is because I absolutely love this textbook. It's very, very useful. Another piece that will help you be successful is work through the example problems in the textbook. It does a really good job of building them out. There's a lot of variety to them. You should be checking them out. Some of the example problems in the textbook are very, very similar to questions that I give you in your quizzes. So if you do have a question on a quiz, check your textbook. It's a good place to do it. Some people will go check. Because I'm writing these myself, fine, go check. I don't care. If you find a question on there that's identical to what I've given you, awesome. Nice. Way to be resourceful. It really doesn't actually hurt me that much. But that's the reason why I'm not giving you homework assignments out of the book anymore. Be resourceful. If you find a resource that helps you, use it. We're going to be doing coding in this class. Show up to class. If you don't show up to class, you're going to miss stuff. We do a lot of very challenging things, and that's going to require your presence in the class. If you're not here in class, you're not watching, there's an issue. Because you're going to fall behind, and you're not going to understand what's going on. And then you're going to come, and the questions you're going to ask me are, hey, I have no idea what's going on in the class because I haven't been here in the past 3 months. I can't teach you everything in one session. This is a challenging class. You have to be on your game. We're going to move at a fairly rapid pace because we have a lot of content to get through. I'm always amazed because in this class we start talking about resistance circuits, and then by the time we're done with resistance circuits, everyone's just like, I feel like I'm starting to understand stuff. And then we move on to capacitance and inductance, and then everyone's just like, no, because it goes from things make sense, and yes, that was friggin' hard, to things don't make sense, and this is even friggin' harder. And it goes really fast. By the time you get done with this course, we will have covered a lot of material, and your brain will hurt. And I will sit back and drink your tears out of my mug, and I will do so with a smug grin on my face. So you gotta be present. You gotta be doing the work every week. You gotta be keeping up. If you do have like baseball or something that's preventing you from coming to class, you're going to have to be proactive about this. I'm sorry to say this. I know this is a challenging semester for all of you. You got to stay up on your game in this class. This class will eat you alive if you start falling behind. Part of being an adult is being able to handle this. We've graduated several baseball players from our program. These students do fine in this class because they ask questions, because they're deliberate, because they manage their time. Okay, you can take the excuse of, wow, I got all this other stuff to do. You got to manage your time. Okay, something's got to give, and if your education is what's giving, you're doing something wrong. So, just okay. So that's fun discussions. Let's go ahead and talk about Raspberry Pi material. So, now this is the document that I've posted on Canvas. I'm just going to step through this really quick. The Raspberry Pi is a really, really cool piece of technology. If I go ahead and pull up one of these, ignore how many tabs I have open, but if I go ahead and pull up one of these, this is what a Raspberry Pi looks like. They start at 35 bucks. Most of the ones that I've bought have been about 55 bucks because I buy the 4 gig versions. There are 8 gig versions now that I believe are either 65 or $75. Yeah, I own one of them. But this is what it is. This is all that a Raspberry Pi is. It's got a processor. Um, oh, there's the processor. This is the RAM chip. It's got the input-output ports. It does have 4 USBs. These 2 are USB 3s, which it's really wasteful to use your keyboard or mouse on there because they don't require USB 3s, but whatever. There are 2 micro HDMI ports, and then it does use USB-C power. So in order to get this thing to run, you are going to need to have a USB-C power source. It's got to be able to provide at least 2.5 amps of power. It's a 12.5 watt charger or more, because it does have to produce 5 volts. So 5 volts at 2.5 amps, well, it's 12.5 watts. So you're going to need that. You're going to need this. There is a micro SD card chip slot down here. I don't know if it shows it. There's a micro SD card right there. It's sticking out. Doesn't really show that all that well. But you will need a micro SD card. I usually suggest a 32 gigabyte one. Had students buy 128 gig and they didn't work. Now I have seen a kit online that does include a 128 gig SD card into it. I'm hesitant to buy that because, again, I just have not. I've never seen it work, but I know the 32 gig work. You get a 32 gig, we will flash them in class. I'll show you how to do it, because flashing is it's really cool. Okay, no, sorry, it is not cool at all. But it's really simple. I should say simple instead of cool. I'm such a nerd. Dang it! Whatever I want, gosh. So this is what the Raspberry Pi looks like. As I've said, you're going to need a power supply. Here's an example of a power supply cord. It's a USB-C, and surprise, it's got at least 12.5 watts of power. Oh, that's a bad day. Of course, it's going to freeze up because, you know, using Word is so computationally intensive for my computer. All that word power. Woo! We are wording it up today. Word to your mother. I regret a lot of things right now. I really do. I don't know why following a hyperlink in Word is what's finally gonna break the word camel's back. Anyways, I'm coming back here to look at myself on the stream as I look at my Streamlabs setup. Oh look, it finally did something. Hey, there it is. I do not know why that took so long. But this is it. It's just USB cable. If you look at the specs here, according to this spec, it does have 3 amps, which means this would be a 15 watt power supply. That works. Anything more than 2.5 amp is going to be good. I like a 3 just because I like being a little excessive. Other pieces that you're going to need, you will need a micro HDMI to HDMI cord. You can buy these individually online. You're going to need, I would suggest getting a case just because it's nice to have your Pi in a case. Now do keep in mind that we are going to be accessing the I/O pins. I/O pins, by the way, are these pieces here. So we are going to have to be plugging stuff into those. So if you can buy a case that makes that accessible, that's great. If you don't, we can always, I mean, you can work outside of the case and then keep the case for when you just use your Raspberry Pi for coding. I suggest everybody get a cobbler. This includes a ribbon cable. This allows you to plug your Raspberry Pi into a breadboard. I'm going to show you what it looks like quick. Again, you can follow all these links yourself because you have this document. But this is the ribbon cable. This is the cobbler. This is specifically a T cobbler because it is a T shape. You take this, you plug it directly into a breadboard, and then you can access every one of these pin outputs directly using a breadboard connection. So that's what a cobbler is. You will need a keyboard and a mouse. Like I said, your Raspberry Pi doesn't come with them. We do have keyboards and mice in the lab, so if you're only using your Raspberry Pi in Lead 233, you can just use our keyboard and mouse. So that's not a problem, but if you want to use your Raspberry Pi outside of that, you will need, you will need to have both a keyboard and a mouse. As I've said, you will also need a micro SD card. A lot of these you can buy them for less than $10. It's not a bad idea to just get an SD card. I also suggest getting an electrical component kit. This includes some LEDs, wires, some resistors. There's a lot of pieces here that we will be using in this class, and that are kind of fun to just have for yourself. We do have all of these components ourselves, so again, it's not something that you have to buy if you're the savvy person who wants to buy a Raspberry Pi but doesn't want to buy too many things you don't have to. If I were you, then I would just get the SD card, the power supply, HDMI cable, and the Raspberry Pi. It's the bare minimum of what you need. It's also suggested that I would suggest that you get a toolbox. I carry all my stuff in a toolbox just to keep my Pi safe. You can use a bag. I really am over the top here because Raspberry Pis are definitely my favorite thing to do. So I'm going to go ahead and wrap up this piece of the lecture and move on to the next one. So feel free to send me an email if you have questions. Otherwise, I probably won't see you this week. And by everything I can determine, I probably won't see you next week either. So I'll see you in like 2 weeks. Which sucks. But anyways, I'll let you know if that changes and if we do